So you should place the PI of your vertical curve coinciding with the PI of your horizontal curve. Anywhere like that you should do, if you are having only one curve. So these are the criteria. Let me repeat. First, the grades, the grades of the arms should not exceed the maximum level, 8% in my case. Second, the earthwork volumes must be close, cut and fill volumes must be close to each other. Third, there must be at least 60 meters gap between the beginning or the end of your horizontal curve until the beginning and the end of your vertical curve, or you may coincide the point of intersections of both vertical and the horizontal curves in the same vertical location, as in this example here. Because in my project I want to have two vertical curves for demonstration purposes, so that you can see at sag type as well as summit type curves, I will have two different curves in my project. You don't have to do that. Only one curve is enough for you. So let me prepare another polyline starting from the beginning somewhere here and another point there at the end of the project. Okay, so I decided actually to have two curves. One of them is going to be sag, the other one is going to be summit. So something like that. I am going to make sure that the slope of this arm between here and there is smaller than 8%. The slope here is smaller than 8%. The slope there is smaller than 8%. Okay. How can you check that? Very simple. Using the measurement tool, click on that point and that point. Click on this point and that point, and then read the height of this triangle, 16 units. Don't forget to convert it by 1 to 200, and here 104 units, 1 to 2000. Then opposite divided by adjacent is your slope. Do the same thing for the other arm. Again, opposite divided by adjacent. Okay, they should be smaller than 8%. Okay, then I will also check that if I put a curve here, a vertical curve, I need to calculate the L distance. Then at the end of my curve, somewhere here, it should be the distance from the end of the curve until the beginning of my horizontal curve must be greater than 60 meters. I have to check that as well. Also, the earthwork volumes must be close to each other. So let me show you my practice here. This is, for example, joining A and B with a single line. Okay, huge difference between cut and fill, and also quite expensive solution. So here I have two curves, one sag, one summit, and I compare the cut and fill quite close to each other. So therefore I decided to accept this final grade as my profile after I check some other things as well, like 60 meters checking, etc. Okay, in the meantime I have placed my red color final grade line. As I said, I have two curves, a sag curve here and a summit curve there. Now we are going to start calculating the elevations of this red color final grade projection for each cross section. The first one, cross section A, is at 54 meters because I know the elevation of that point B, point A. The next one is not on the same elevation as the original ground. It's different. So the easiest way of doing it is to draw a line from the first cross section upwards when the ortho is on, and then measure the vertical distance from this point, from this point to the datum line. In my case it is 762. 762. 7.62 divided by 5 because of the scale 1 to 200 plus 53, and that is 54.52. 54.52. Copy this. And you can delete this line now. Let's do the next one. Another line from cross section number 2 upward when the ortho is on. Measure the distance from this point till your datum line. 1024 divided by 5 plus 53, 55.05. And delete this line. Okay, now one by one you need to do for each cross section you need to calculate the elevations of this red color final grade line, but don't forget we will have a curve here, therefore the elevations will change around this area, so we need to update. Also, because I have two curves, another curve here, the elevations of the red line will change around that area. We need to update after the curve calculations. So I'm going to show you the curve calculations in my next session.